Hi everyone, and welcome to our video on finding the simplified form of the difference quotient by using our properties of average rate of change. All right, so our previous video, if you've been following along, I made an edit, so this is all cleaned up. So if you have um, the newer notes, then you'll be in better shape. If you were following the old printout, you just probably need a full new sheet of paper. Okay, so this is all this one, and I added a little column that can help too. All right, so in this problem, we're finding the simplified form of the difference quotient. Okay, so the difference quotient is this. And we'll just write that in. Let's put it down below this time. So we have f of x plus h minus f of x over h. And we just want to break those into pieces. So we want to do this. And that's the biggest step. So let's break that down. So right down below, I'm just going to write out our f of x plus h and keep it in blue. Remember, with a function, it's just saying change that x that I'm underlining and this x that I'm underlining with the parentheses into x plus h. So we'd have negative 10 over x plus h, just like that. And we can even keep the parentheses. There we go. Okay, so that is actually all there is for this one. So I just said, oh, sometimes it takes a long time. Not this time. Okay, however, it's a fraction, so that could come back and maybe get us. Okay, but let's see how it looks. So keeping my colors, I've got negative 10 over x plus h. And then there's a minus, and then f of x. Okay, so f of x I'm going to do in red. F of x is just the original function. It is just all that. Okay, so f of x is right here. It's saying just do negative 10 over x. And then still over h. Okay, so that h, just don't forget about it. Okay, and then we'll clean this up a little bit. Okay, so notice there's a negative, or the minus, and then the negative to the right here. Let's highlight that. So these would become a plus. But then after that, it doesn't really change anymore. So we still have negative 10 over x plus h plus 10 over x and then over h. Okay, and then let's put this parenthesis and this parenthesis in. So the whole big numerator and the whole big denominator in parentheses. Well, this numerator has these, let me even put that in parentheses too, has those small denominators. So this is what's called a complex fraction. So a fraction in fractions. To eliminate the complex fraction, what we're going to do is multiply the big numerator and big denominator by the product of the small denominators. Okay, so that's these are the small denominators. So we're going to multiply the whole big numerator and the whole big denominator. Let's do that in purple. Let's do it in green. This whole big numerator and this whole big denominator are going to get multiplied by the product of that in the blue. Okay, so I'm going to squeeze that in right here. The product is x times x plus h. And then whatever we do to the top, do to the bottom. There we go. And let's extend that. Okay, so the reason that we do this is because when this distributes, so this now distributes to both terms in the numerator, we're going to get, let's set up our big old fraction bar. We're going to get, well, when, again, this whole thing in green multiplies this left fraction, this x plus h and this x plus h will cancel when it multiplies. So that means we would be left with the negative 10, and then the other x in green there just attaches to it. And then that's the big cleanup, or at least part of it. And then now we do our plus sign. And then, again, this whole thing right here is still multiplying into this. Okay, so when it multiplied the first term, we did a little simplifying, but now we're back to this whole big thing. However, when it does multiply, this x and this x would cancel. So we'd be left with this x plus h multiplying the 10. So we'd have plus 10, and then parentheses, x plus h, over h times x plus h. Okay, the other way to think about this is this x, it's kind of like cross multiplying, multiplies that 10, or negative 10, and then this x plus h multiplies that 10, so 10 times x plus h, and then they both multiply each other and are put down below. Okay, so you could say, oh, it's like cross and then put below. Cross and put below. Okay, so whichever method you like is fine, as long as we get to here. And then we would distribute. Okay, so the positive 10 multiplies each of those. Big fraction bar. So we have negative 10x plus 10x plus 10h. Whoop, I pushed a button. Let me scroll. Plus 10h over h times x plus h. So usually we don't multiply the denominator. We just leave it like that. Okay, and then now we'll start to simplify. We see, oh, these are the same, but they're opposite. So those zero each other out. And we're left with a positive 10h up above. So we have 10h over h times x plus h. There we go. That is the simplified. Oh no, it's not. I went one too soon. Sorry. One more step. I was getting excited. Okay, so notice in our numerator we have an h, and in the denominator we have a product that has h in it. So that means this h and this h will cancel. Now it will be simplified. So now we've got 10 over x times x plus h. Okay, so that is now the simplified difference quotient. I'm going to keep my highlighter actually, so I'm going to rewrite it in there, but this is that difference quotient. Okay, so 10 over x times x plus h. Okay, so all of that was, oh, let's put it right here. That's why I put it there. 10 over x times x plus h. Okay, so there it was, x. Okay, so that is our difference quotient. Oop, I could just, boom, arrows to arrows. Okay, so we found it. Now we're doing what they want for step 2. So the difference quotient we found, now the rest is filling this table. And so we'll plug in x is 2 into this equation there. So that's what this far right column's for. So when we plug 2 in, we're going to get 10 over 2 times 2, and then we're going to plug the h equals 1 in, plus 1. And then a calculator can help here. So if you do have a calculator, I mean, that's fine to use. I still have a little bit of scratch work to the side. So it looks like this would be 10 over 2 times 3 is 6. And then that would be 5/3. Okay, so I'm gonna leave that as a fraction, and also let's get the decimal real quick. So that would be 1.67 to 2 decimals. Okay, so that's that one. Now we're doing the rest of them. Okay, so again, it's just setting it up. I have 10 over, still the x is 2, so 2, and then 2 plus, this time it's 0.1. Okay, so we've got 10 over 2 times 2.1. Now this is where a calculator will help. I have a calculator just on my table here, so you won't see me do the operations, but I will simplify it. Okay, so I'm going to prefer the decimal. And when we do the division, it comes to 2.382. to 2 decimal places. Okay, so it is to simplify. Okay, and then now let's plug in x is 2 again. So 2 times 2 plus, this time around though, 0.01. All right, and then we'll do that. I'm going to do it off to the side. Okay, so in the calculator, we can plug this in, and we will get 2.49 to 2 decimals. And then one more time, 10 over 2 times 2 plus 0.01. Again, I'm going to just do that in my calculator on my table here. 5 divided by, oh, I didn't put the decimal in the right spot. There we go. So 2 zeros and then a 1. Okay, so divided by that. And that gives us 2.50 rounded to 2 decimals. Okay, so we're getting these numbers. So it looks like it's getting closer to 2.5 as we go. So 1.67 is kind of far, and then these are getting closer to each other. Okay, so again, either way, all it's stating. Okay, so that graph, f of x equals negative 10 over x, looks something like this. And they're saying, okay, so when you have x equals 2 and you go a length of h over, you have this slope. Okay, so if we're at x equals 2 and we went over 1, oops, let's mark it 3. Okay, so that's that h distance. Then we get this line through those 2 points, and we get that slope. Okay, so they're saying that's that slope right there for this case. And let's just do one other. Let's go to red. And then they said, oh, make it even closer. So that's going to be this case. If I go over only a little bit, we've got that new slope, which we can see, oh yeah, is steeper, 2.38. And so these ones are getting closer and closer. So as it gets closer, so these values aren't very far from 2. So it's just saying your slope is just getting a little steeper each time. Okay, so that's going to be important for the next section, so in the videos that are coming up. But right now, that's all we want to talk about, is that it's just a special slope, and it takes a while to get to. Okay, so stay patient with these. But other than that, let me know if you have any questions, and thanks for watching.